In this video, we're going to solve the following limit. Limit as x approaches 9 of 3 minus square root x divided by 27 minus 3x. Okay, so we haven't seen a limit like this before. The first thing we check is if we can just plug in 9, but if we plug in 9, we'll have 27 minus 27 on the denominator. You don't think that's going to work, but notice that if you plug in 9 on the top, you get 3 minus 3. So there's probably something that we can do to this limit algebraically to make it solvable. Now, if you notice that we have a radical in the limit, so we want to get rid of that. So we're going to rationalize. Now remember, if you have a expression, a plus square root of b, then the conjugate is a minus square root of b. You're really just taking the same expression, but flipping the sign, okay? So if you look at this expression, to rationalize it, we multiply by the conjugate. Okay, so we have the limit as x approaches 9. So if we have 3 minus square root x, that's the form a minus root b. So we're going to multiply the top and the bottom by a plus root b. 3 plus root x divided by 3 plus root x. This is all inside the limit. Okay, and then we're going to carry out this multiplication on top and on bottom. Alright? So 3 times 3 is 9, minus 3 root x, plus 3 root x, minus x. Okay, and this is the whole point of rationalization. Since the sign is different, the radicals go away. Okay? And let's just pause on multiplying the denominator out right away. Let's take a look first and see if we need to. So I'm going to rewrite this without those crossed out terms in the middle. Okay, and do we really need to multiply out the bottom? We have 9 minus x on top. Look at this term. This looks very similar to 9 minus x, right? What if we factored out a 3? I'm taking a 3 from this term and left over with 9 minus x, right? And that's good. These cancel. That's the problem term. It's gone. The denominator is no longer a problem, so we have the limit as x approaches 9 of 1 over 3 times 3 plus root x. Okay? We can go ahead and plug in 9, right? Put in a 9 right there. It's going to be equal to 1 over 3 times 3 plus root 9. That's 1 over 3 times 3. 3 times 6. 3 plus root 9 is 3 plus 3. So it's 1 over 18. Okay? So we were able to rationalize to get rid of this radical, and then it ended up canceling out nicely with the 9 minus x terms. So if you ever see a limit problem with a radical in it, even if it's on the top, you can use rationalization with the conjugate as as one of your techniques. Usually they're set up so that they're easily solvable once you rationalize.